All right, here's our next video in section 4.1. We're going to cover example number 3 and 4 in this video. We started talking about exponents in the past, where we've talked about adding and subtracting, where we've talked about multiplying, raising to a power, and dividing, and what we do with the exponents when we're doing those different operations. Let's talk now about what happens if my exponent happens to be 0. Really, anything raised to the 0 power is 1. Huh? That kind of sounds weird, right? You would think that would maybe be 0. Let me show you an example of why it's actually 1 instead. So look at this example here. If I have x cubed divided by x cubed, what we've seen in the past in other math classes, if I have, 4 divided by 4, isn't that 1? 7 divided by 7 is 1. And so x cubed divided by x cubed, really, shouldn't that just be 1? But what would actually happen if I use my exponent rules like we did in the last video? Where if we have like bases, which we do, they're both x's, shouldn't I be able to combine those into the same base but subtract their exponent because I'm dividing? And so 3 minus 3 is really x to the 0. So that means x to the 0 is the same thing as 1, right? I know, seems kind of silly, but make sure you remember that. Anything to the 0 power, x to the 0 power, really is just the same thing as 1. Anything to the 0 power is 1. Let's apply that rule and do some of the examples here. So I've given you a couple of different examples in example number 3. Some of them look really similar, but there's just a little bit of a difference that makes a big difference in how you approach these problems. So be careful. All right, remember anything to the 0 power is 1. So if I have 1,948 to the 0 power, I really just get 1. All right, look at B. I have -9 to the 0 power, where the parentheses are around that -9. So I know the whole thing, the whole -9, is raised to the 0 power. Well, anything raised to the 0 power we know is 1. All right, look at C. The whole thing, the 3 and the x, the whole thing is raised to the 0 power. We know that anything to the 0 power is 1. Okay, well, let's go down and do these next 3, where some of them look similar, yet a little bit different than the first 3. Look at D here. D looks a little bit different than C. You notice that in D there are no parentheses. And so on this one, really the only thing raised to the 0 power is this x, correct? And so I have a coefficient of a 3, and then I have x to the 0 power. And so my coefficient should stay there, and the only thing raised to the 0 power, this x to the 0, turns into a 1. And so really I have a 3 times a 1, and so your final answer should be 3 on that one. Because there are no parentheses, to me that tells me the only thing raised to the 0 power is the x, so x to the 0 power is 1, but there's that coefficient of a 3 that's still there, so don't forget about him. All right, look at E. On E, I have -1. That's a coefficient. And I have 9 raised to the 0 power. The only thing that's raised to the 0 power is the 9. And so 9 to the 0 power is 1, right? And so I really have a -1 times a 1. And so my final answer on this one is -1. All right, look at F. F's a little bit tricky because on F, 9 is raised to the 0 power. But wait a second, what's that negative doing there? Well, it looks a little bit different than B because B had the negative inside the parentheses. That means the whole -9 was raised to the 0 power. On F, what this is really saying is that I have a coefficient of a -1 and I'm multiplying it by 9 to the 0, or I'm doing the opposite of 9 to the 0 power. Well, we know that anything raised to the 0 power, 9 to the 0 power is 1. And what's the opposite of 1? -1, right? Or I could say that there's a coefficient of -1 and it's being multiplied by 1. So I get -1 as my final answer. So parentheses here make a big difference on what is raised or not raised to that exponent. So be careful with that one. All right, let's talk about what happens when we raise to a power. This is part of our rules, right? All night, my aunt ran mail downstairs. Well, that's the R and the M. Well, when we raise to a power, we take an exponent and we raise it to another exponent. All we're really doing then is combining, and we're going to multiply the exponents. So let me show you an example. If I have y to the 5th and I want to cube it, well, doesn't cubed mean I have 3 of those same exact things that I want to multiply together? So y to the 5th cubed really means I have y to the 5th times another y to the 5th times another y to the 5th. Well, if I have 5 here and another 5 here and another 5 here, how many y's do I really have altogether? Well, don't I have 15? So you can write it all out. Or instead, what did I just do with the exponents? Well, I can just multiply them. And so anytime I'm taking a power and raising it to another power, I can just multiply the exponents. Let me show you some examples here. In example number 4, I have m squared to the 5th power. That means I have 5 of these m squareds, right? 4, 5. Really, how many m's do I have altogether? Well, I have m to the 10th, right? Or I could have just more quickly multiplied the exponents together, all right? Look at b. I have 2 cubed raised to the 4th power. So I have 2 cubed times another 2 cubed times another 2 cubed times another 2 cubed. How many 2's do I really have? Well, I end up having 12 2's, or 2 to the 12th power. All right. Make sure that you practice those next couple of rules that we just talked about. 0 as a power, remember anything to the 0 power is 1. And then we talked about raising a power to another power. Practice those few before we move on to the next video where we will finish off section 4.1. Let me know if you guys have any questions.